Cool. Just give it another minute or so. Let someone trickle in. We'll get going. Appreciate you guys all coming. End of the show, last hour. Hope you guys had a good CannaCon here in Chicago. How many growers we got in the audience? Good amount. There we go. It's the audience I wanted. All right, well, I guess we'll kick some stuff off here. Thanks for coming. I want to thank the organizers of the event, too, for giving me this opportunity to speak to you all today about something that's near and dear to my heart, which is cannabis phenotypes and phenotypic expression. And really what we're talking about today is the uniqueness of cannabis varieties and how we can maximize the expression of each one of these cultivars that we have in our grows. Now, there are more desirable phenotypes and there are less desirable phenotypes. Then there are some varieties stacked with so many good traits that it's like you just found a unicorn or something. You know, it's a keeper. You know, it's that one you never want to let go. The variety is really what keeps cannabis fun and interesting for a lot of us. It's what's driven my passion in the industry for the past 10 years. The smells, the colors, the effects, everything. You might have heard of Skunk 1, Chem 91, Northern Lights 5, all the Girl Scout Cookie and OG Kush phenos. And those numbers and names is what we're going to talk about today. You know, how they come about, how they are found, and why the environment in which they are grown is so crucial. So who am I? Well, my name is Anders Peterson. Yes, like the guy from Workaholics. So if you like that show, feel free to call me Durs. All my friends do. By trade, I'm a molecular biologist, but I've been working in the cannabis industry for 12 years now, primarily in the Oakland and Berkeley area of California. I run indoor grows, manufactured concentrates, infused product kitchens, ran dispensaries, and my passion really lies in optimizing indoor cultivation facilities with data, technology, and genetics. This brought me to my current position here as a Cannabis Operations Specialist for Inspire Transpiration Solutions. In Inspire, we specialize in integrated HVAC for precision control of indoor environments. As an indoor grower, HVAC for me for many years was a four-letter word. It was a liability in my garden. It was not a tool that I could use to increase my plant performance and optimize my facility. So I joined Inspire because, I wanted to be a part of a team that was tackling that problem and producing solutions that empowered growers to finally get control of their rooms. But enough about me. Let's jump into the topic at hand today. What is a phenotype? Phenotype, the set of observable characteristics of an individual resulting from the interaction of its genotype with the environment. And regarding cannabis, phenotype describes the plant's physical appearance, its biochemistry, its behavior, its developmental growth. The key words to focus on here are genotype with the environment, that interaction alone. Keep that in mind. And in fact, this definition is often distilled into an equation. Genotype plus environment equals phenotype. If you learn one thing from today's talk, that's what you should take away. Genotype plus environment equals phenotype. So really there are two factors that generally influence the way a plant grows. The genetics and the environment. The environment is 50% of the equation. Okay? Now the term phenotype can be used in two different ways generally. It can refer to a singular trait, like I have this plant with a purple flower pheno, this plant has a green flower pheno. Or it can talk about the accumulation of all of the traits on a plant. So this plant has a more desirable phenotype than this plant over here. And I know, science, right? We make it confusing, dual meaning. Well, scientists tried to clear that up by using the term phenome, kind of like genome, but it was never really universally adopted. So we still use phenotype to describe both situations, a singular trait or an accumulation of all the traits. Another nuance to this definition is observable. And that doesn't mean just with the naked eye. It can also be a trait that can be brought out through some technical procedure. So like in humans, our blood type is a phenotype of us, but we can't see it with our naked eye. Same thing in plants. And we have a fancy term for that in cannabis called chemotype, or the chemical phenotype. This is describing all of the chemical ratios of cannabinoids and terpenes expressed. And typically you'll see this on a lab report as the chemotype, the actual chemical, technical difficulties. So now that we have a base understanding of what a phenotype is, we're going to dive into what a genotype is, a quick refresher on gene expression, and some examples of how the environment can affect the expression of these genes that we see in our rooms. So what is a genotype? An organism's complete set of genetic material. Although genotype is often used to refer to one gene or a set of genes in a genome. I like to think of genotype as the basic genetic boundaries which define a range of phenotypic possibilities. The genotype sets the stage. That's kind of how I think about it. So just like humans, cannabis is diploid. It has two homologous copies of each chromosomes. One copy from the male parent plant, one from the female parent plant. Each chromosome in the pair contains the same genes in the same order and place along the length of the chromosome. So we have these little distinct genes that are coding regions, and we have other parts of the genome that don't code for anything. These genes then get expressed into the phenotypic traits that we observe. A segment of double-stranded DNA undergoes transcription, forms an RNA transcript, then is translated into a functional protein. And this is a pretty oversimplified example here that you're seeing on the right of this purple pigment gene, as I've called it. But it's a great way to kind of like see how this all works, right? DNA to RNA to protein, and in this example, this protein creates the pigment that creates our flowers to become purple. So the result is a purple flower pheno. But how do we relate genotype then to phenotype? How do we connect the dots here? Well, during the expression of these genes, a lot of variability is introduced. Punnett squares are used by biologists to determine the probability of an offspring having a particular genotype. It shows all the possible combinations of paternal and maternal alleles. So on these Punnett squares, if you took in biology before, you've probably recognized these. And you can see the big T is an allele. It's one variant of the genotype, and the little t is also an allele. It is another variant. In this example, big T is dominant, little t is short plant. We have each allele in a genotype represents each leg of a chromosome. So we have the male and the female, they're crossing, and we get to predict what genotypes the offspring will have. If you've taken genetics, this is called a monohybrid cross. It's a 3-to-1 ratio. So we get an idea of what the genotypes are going to be. Big T, little t. But can we predict the phenotype using something like this? Not really. We can kind of guess, we can make some inferences, but it's not going to be 100% exact. And that's because Punnett squares are missing an important factor again, the environment. And I'm going to keep saying it over and over and over again until you guys get sick of it by the end of this talk. So some traits are largely determined by the genotype alone, while other traits are highly influenced by the environment. This can be described as phenotypic plasticity, the ability to vary phenotypic expression in response to environmental conditions. And this kind of makes sense, right? I mean, think about it. Plants are sessile organisms. They can't move. If they're stuck in an unfavorable environment, they have to adapt. And so over millions of years, these plants have developed mechanisms to do just that. And this is why you can give 2 clones with the same genotype or genetics to 2 different growers, two of you guys in the room here. Take it to your grows in different areas, and your results will not look the same. They might be pretty close, but the environment in which they're grown are going to alter the end product. It's like the whole nature versus nurture conversation that we have, right? About people. So, plant growth rates, morphology, like the structure of the plant, internodal length, height, and timing of plant development. So time to maturation, how quick does your flower finish, are all areas of plant growth that are generally considered plastic, meaning we can influence them and steer them with the environment. They're not preset and determined. Let's go through a couple examples of this, some of them you might be familiar with. And so, again, these are things that we can take advantage of as growers by altering the environment to elicit beneficial responses. Anthocyanins, fancy word for purple weed that we all know and love, right? These are the pigments that are responsible for all the purples, pinks, and colors that we see. And one thing that, years ago during Prohibition, I started growing 12 years ago indoors. In that kind of ignorant stage in my life, I thought all weed could be purple as long as I got the room cold, right? But what we have found is it's very genetic determined. You have to have, again, that genotype base that produces those genes to produce anthocyanin. So in that example we showed of that protein that produces purple pigment, okay, you have to have that gene first and foremost. But the level of expression, the level of color that is generated can be maximized or limited by the environment that genotype is produced in. So, for example, like I said, we used to think we'd have to get our rooms to 65F the last couple weeks of flower, and get it really cold. People are even putting ice cubes in their reservoirs, ice cubes on top of their pots, saying, oh, this is how I get purple weed, right? But think about it, right? The colder we get these rooms, the slower the metabolism of the plant gets. And so we're sacrificing yield, we're sacrificing productivity, and overall, maybe we get a little bit more color. Great. Maybe you get a few more bucks per pound when you're selling it wholesale. But on the reverse side, say we run our room warmer. We now get more capacity out of our HVAC system. We get better control over relative humidity. And are we going to really sacrifice color? Who knows? That's been kind of the age-old question for a long time is, what temps do I need to be at the end of flower to not sacrifice yield, but also maximize color? And what I've been finding, collecting a bunch of data from these rooms, I'm pouring through trend data and sensor data every day, is that realistically, you can finish your room at 80 degrees the last few weeks. But if you drop that nighttime temp, maybe 5, 10 degrees, you get just as much purple as if you brought that daytime temp down to 65. And you're also not sacrificing the productivity of your crop at the same time. So it's that balance, right? So you don't want to get too hot towards the end or you will lose some color, but too cold, lose yield. Another example of how the environment can steer and influence the phenotype is this thing that we call the day to night temperature differential, or just DIF for short. So with a slightly warmer lights on temp and a slightly cooler lights off temp, we have what's called a positive diff. This positive diff promotes stem elongation or stretch. And there are situations where we want that stretch. So for example, you have a really slow vegging cut and time constraints happen in your garden, you got to move things around. You might employ this to get a little bit more height out of your crop the first weeks of flower so that you can get better light uniformity with your other cultivars and maximize lighting potential in the space. On the flip side, if your nighttime temperatures are slightly warmer, in this example, 85 lights off, 75 lights on, you have a negative diff, and this can suppress stem elongation. And if anyone here has grown GMO before, or garlic cookies, they know how much of a pain it can be the first 3 weeks, because it can sometimes triple in size really quickly. Certain cuts can. And so you can use some of these techniques, defoliation techniques, certain foliar feeding techniques, to prevent that stretch from happening. So again, we're using the environment as a tool to control our phenotype the way we want. Really, a prerequisite to influence phenotypic expression with the environment is control. Without control, it's just uncontrollable stress to the plants. Crop steering is about purposeful stress to get a beneficial response. But if you don't have the control of all of your growth parameters, it's uncontrollable stress, and more likely than not, you're going to cause more harm than benefit. So control of all the plant growers. And for me, obviously I'm a little biased working for an environmental control company. Temperature and relative humidity is what I focus on quite a lot and what I have a lot of data on. That's what I want to show you today. Now, in these graphs here, I'm comparing two different types of HVAC systems. An integrated HVAC system, which couples in dehumidification with the cooling, heating, air movement, and air cleaning capacity. One system, one brain, a lot of function and form out of one piece of equipment, compared to how we used to build our rooms, conventional, non-integrated. You have split system, 5-ton units with standalone dehumidifiers in the space. Disparate pieces of equipment, sometimes are hard to get them to communicate with each other. And that's what you're seeing, the level of control in these trend graphs. In fact, these are two different flower rooms in the same state, both in week 4 of flower, both 2-tier, both using LED the same week in June of this year. So it's a very good, it's not a true side-by-side by any means, but it's as close as I could possibly find to compare these two systems. And you can see the level of control day to night. Red line on the top there on the left with the integrated system. Day to night, every time, within a couple degrees all week long. Relative humidity on the bottom line, within a few percentage all the time, no spike. On the right, with the conventional non-integrated, the purple is the relative humidity, yellow is temperature. You're getting some control of temperature, but it's definitely fluctuating. And on relative humidity, it's all over the place. We're seeing 15, 20% relative humidity spikes. And what's that going to cause? That's going to cause poor plant performance. It's going to cause sporulation of powdery mildew, because we know it's not about high relative humidity to cause PM, but the fluctuations that bring out PM. And so these spikes are going to add up over time. This is going to be a lack of CO2 assimilation. It's going to be a lack of yield. And if you think about maybe, okay, it's only 7% of my day, but 7% of my day, every day of my cycle is going to add up to a large portion of my crop being negatively impacted by poor environmental control. So control is really the prerequisite here. Control also gives us some other cool things as well. In one way or another, all of the cardinal parameters of plant growth are influenced by your climate control system. Some of them are more stretched than others, but I think you can see how at one way or another it's all connected. And quality, quantity, consistency, and efficiency is what I like to preach when I'm talking about optimizing these businesses and dialing in your facility. That's the core 4 pillars of performance for these businesses. And quality, quantity, consistency, and efficiency is all about optimizing all 10 of these parameters, every single one of them, and having control of them. If you focus on control of all 10 of these parameters, then you can design a facility to drive any cultivar that the market demands. Build a facility with limited control, and the choice of high-performing cultivars will be limited. Environmental control is 50% of what makes up a phenotype. Don't forget that, right? Also, having control allows us to take advantage of some more advanced cultivation techniques, like VPD. I remember when VPD came out, it was a hot button word all the time, and I wanted to learn all I could about it. So I grabbed a VPD chart, and then I quickly realized I couldn't hit the targets it was telling me to hit. So it was kind of a futile endeavor for me because I didn't have the control of my space. When I had control, I can start actually taking advantage of VPD. And for those who aren't familiar, VPD it drives water movement through the plant. It's literally the pressure that sucks water up from the roots, through the shoots, through the stems, and out through the leaves. It's the horsepower that drives all the other processes in the plants. So it's going to allow for nutrient uptake, transpiration, carbon assimilation, improved photosynthesis. It's going to help evaporatively cool the leaf surface and keep the leaf temperature stable. And when I'm talking about leaf temperature, that's another big aspect of VPD. If you grab a VPD chart you have to know the leaf temperature offset. You can't calculate VPD without knowing the leaf temperature. Okay, so this chart I made myself is a -3 degree leaf temp offset. And that's the average that I typically see in LED rooms when I'm measuring it with my emissivity adjusted IR gun. I'm typically seeing my leaf temperature 3 degrees cooler than ambient in most LED situations. You plug that into a VPD chart, it calculates with that offset and gives you these values. Then you can start trying to target ranges. So in this one, I plugged in 1.0 to 1.5 in the blue sphere here. I'm going to start closer to 1 at the beginning of flower, and I'm going to inch towards 1.5 towards the end. Then you pick the set points that your equipment can best achieve. With more control, you have more options. So by keeping your plants in this appropriate ranges, it'll keep them healthy, thriving, and allow you to get the most out of your genetics. Okay, switching gears here a little bit. Can't talk about phenotypes without talking about pheno-hunting, right? One of the most fun things to do as a cannabis grower is popping seeds and hunting for that new pheno, right? That new, everyone wants it. It's why I'm still here today after 12 years thinking about genetics every day. And you know, if you come from other industries, corn or soy cultivation, for example, you pop 1 million seeds of corn. You go to those fields, they're all from seed. All the plants are the same height, they yield the exact same amount, they're all inbred lines, and it is just uniform, monocrop. There's no variability in corn or soy. Cannabis is just not like that. There's a lot of variability in the genome itself. Due to prohibition, we haven't stabilized a lot of these lines. And really, that's kind of one of the best benefits of prohibition is now us growers get to hunt through that variability and find some really special genetics. And so in just a pack of 10 or 12 seeds, you can get some very stark contrasts and differences once you pop them, grow them out, flower them, harvest them, and consume them and try it. There's quite a lot of variability. That's why also we use clones today, right? The reason we're all using clones still is because they're uniform. But before you have a clone, you got to have a mother, and you got to find a pheno. So the process goes something a little bit like this, okay? Let's say I get a pack of 10 regular seeds from the same cross. They all germinate, and I arbitrarily label them in my garden 1 through 10 just to keep track of them, okay? They continue to grow through veg, and then eventually they start showing their sex. Maybe after week 6 in veg, they get some pre-flowers. You can start weeding out the males from the females. Dang it, I got some males. So I'm not going to be breeding. I don't want to keep them around. I don't want pollen in my grow. I'm going to cull them out and throw them away. Keep going, got a hermaphrodite. It's a pretty common thing. Typically, you're going to see more than one herm in a pheno hunt. This is just an example here, but hermaphroditic genetics, sign of instability. And you don't want that pollen to be dropping when you go to flower and seeding out your whole crop, right? So I got a herm, I'm going to cull that one as well and toss it. So it looks like in this pheno hunt, I have 5 females to hunt through. I'm going to let them keep growing. I'm going to put them into flower, and I'm also going to make sure that I've backed up all these phenos and clones in my bedroom before I flip them, right? So as they get further along in their flowering cycle, maybe they start to show a little bit of color. I'm hunting through, maybe phenos 1 and 2 stay green, 3 and 5 start getting purple. All right, looking pretty good. Then they start showing more of their nose towards the end of the cycle. 1 and 2 have a more cakey pheno, like terp profile. And 3 through 5, it's like I just opened my gas tank, super stanky. I like that. They're still going, about to harvest. Number 3 has cakey and gas, and I'm like, ooh, I'm keeping my eye on number 3 for sure. I'm starting to like this one. Okay, so I'm harvesting everything, I'm drying everything, and now I'm able to record the end product and the yield. I've identified 1, 3, and 5 yielded really good. And I think you guys see where this is going, right? 3 had yield, it had a really nice terpene profile, it had a nice purple color, it was easy to grow. That's the pheno I want to keep. I'm gonna run that next time with a full crop. And let's just say I call it gas cake number 3, arbitrarily, right? And that number 3 is unique to me, right? To my garden, to how I labeled it. It was by chance. So when you see that on the shelf of the dispensary, it's not like it's some universal naming convention. It's just how I numbered it in my garden. I'm going to attach that number to the end because maybe I wanted to keep number 1 or 5 too for a certain reason. This is kind of an explanation of how this goes, right? And how this naming convention goes and how it can get convoluted really quickly. Another example of that is all the popular phenotypes of gelato, right? Originally bred in NorCal by Cookie Fam and Sherbinski, or Mario Guzman, that guy. It's a cross between Sunset Sherbet and Thin Mint Girl Scout cookies was the original cross. Funny enough, Thin Mint Girl Scout cookies is a phenotype of Girl Scout cookies. It just has more of a minty menthol terpene profile to it. So they did that cross, and let's say, for sake of example, they had 100 seeds in their first ever gelato hunt. They labeled them 1 through 100, they grew them out, and they identified that the 33rd, the 41st, the 43rd, the 47th, and so on seed in that hunt were the winners. They were truly special. They wanted to keep them. And they were so special that they called them a new name, right? So now they lost the number, and all of a sudden 33 became Larry Bird. And Gelato 41 became Baccio Gelato, which is my favorite pheno of gelato personally. So they had mother plants of this, they cloned it and disseminated it through the industry, and that's why now you can get a lot of these phenos across the country. But see this quality here in these pictures, you're not going to see the same Gelato 41 at every time you go buy it. It's not going to be that quality because, again, it depends on the environment. So these growers and these examples did a very good job maximizing these phenotypes. But there are a lot of other qualities to look out for in a good phenotype than just color, aroma, and yield. And this slide just shows a few of the traits that growers and breeders look out for. Here you see a list of traits that people consider in breeding for commercial cultivation. Things like faster finishing times, better production under LEDs, faster rooting times, higher cannabinoid or terpene content, higher yields at elevation, or drought tolerance, all these things. If maybe you're a solventless guy like myself, I love solventless, bubble. I used to always breed for trichome cuticle thickness, like the skin of the grape. I used to hunt for the right thickness, not too thin, not too thick, so that it survived my wash and survived through the rosin process as well. So you can breed for whatever goals are most beneficial for your business and your grow. And so it's not like you can maximize every single one yet. There's some molecular biologists who are trying. But, select the traits that are most important to you and your goals and look out for them. Also, breed something that people want to smoke. That's first and foremost, right? Like, you can breed for all these traits, but if no one wants to smoke it, you just wasted your time, in my opinion. Another thing with phenotypes is COAs, the certificate of analysis. This goes back to where we started with chemotype, or the chemical phenotype. Now, today, COAs get you paid, right? COAs are how current purchasing decisions are being made at the commercial level and how we begin to correlate medical efficacy to secondary metabolites. Now, as a former commercial buyer back in Prop 215 area, like in California, before it was fully legal and recreational in Cali, it was a way different purchasing process. I'd sit in my office, growers would come and have 10 turkey bags open in front of me. I'd squish them, I'd smell them, I'd smoke them with them, and then I'd negotiate price. It was much more informal. It was like buddies bargaining over bags of weed, Nowadays, I've also been a buyer now under the new regulated environment for dispensaries. The first time I ever had to buy commercial quantities of weed wholesale, I was so upset at myself. I got a spreadsheet and I got lab results. I didn't get pictures. I didn't even get terpene results. And I was like, this can't be how I'm about to buy, 50 pounds of weed or 100 pounds of weed or whatever for my dispensary. This is insane. And so that's why these COAs have become so important for us commercial cultivators, because they're what gets us paid. And by maximizing phenotypic expression, we maximize our COAs, right? This is an example of Fatso testing at 44, around 44 total cannabinoids. If I'm a buyer, wouldn't I spend more on the Fatso at 44 than AK-47 at 18%? Doesn't that dictate value? Sure, there are arguments and things around quality aspects of maybe the highest potency cannabis isn't always the best, But typically that's how it's trending today. You know, the better phenotypic expression sells quicker, higher potency sells quicker, and that's why it's so important to focus on these in your chemotypes of your cultivars as well. Phenotypic expression drives revenue. Now, these are key performance indicators. Key performance indicators are how we benchmark the performance of our business and our garden today. They allow you to future-proof your business for when the market inevitably will compress. And in a lot of states, it already is, right? So you already got to be looking out for these things. Grams per square foot, harvest cycles per year, trim to flower ratio. They're all KPIs that are directly tied to your genetics and your ability as a grower to maximize the expression of your phenotypes. Just think about it, right? Like trim to flower ratio. If I have a cultivar with less sugar leaf in my bud and it takes my trimmers half the amount of time to trim, that just cut my labor costs in half because of my genetics and how I grew them. You know, harvest cycles per year. Most cannabis finishes in 9 weeks right now, right? So we're getting on average about 4 complete turns per room per year in an indoor facility. But if I can select genetics and grow phenotypes that can get me to 5 or 6 flips per year per room, my bottom line just went through the roof, right? I'm making way more money, I'm killing it. And so that's why this stuff is so important, because it really ties back to the finances. So often as a fan of cannabis, I just want to grow good weed so I can smoke it. But I had to learn over the years that it's a business at the end of the day, and we need to pay attention to these KPIs and get to that next level to stay in business and do what we want to do and what we love to do. Once you're able to maximize these KPIs in your garden, then you're able to start strategically pricing per cultivar. Instead of just blanket pricing everything, you can start strategically pricing and saying, look, I did a really good job as a grower. I got a genetic that my neighbor doesn't have. I demand a higher price point for it. And it all stems back to that maximizing of the expression. Now, the biggest limiting factor for phenotypic expression is your environment. Environmental control is 50% of what makes a phenotype, and phenotypic expression is what makes cannabis so special. It's all about control and what you do with that control that drives plant expression and increases financial performance. And thank you so much for coming today to listen to me. I got a few minutes maybe if you guys have any questions, but yeah, really appreciate you guys come listen to me talk today. So, thank you. If not, feel free to head out if there's no questions. But if there's any questions, I'm happy to answer them. Or come up to me and talk to me later. The Bay Area in California.